Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
Welcome, everybody, again to Engineering Tomorrow. I'm your host, Brian Gomsky. Thank you for being here another week. If you remember last week, we were dealing with some floodwaters out here in the valley. That is still the case, though I think it's receded a little bit. So we are here again, and we have some very special guests. We have Kenton Hawkins. You go by Kent, right?
I go by Kenton.
Kenton. Okay. Mm-hmm. Kenton from Envirotech is here, and Stephen Higgins with Midwest Machinery is in the house again. If you're a big fan, he was on some of our early episodes, and he is back. So today we are talking about fan coils, and our expert panel here is going to just start off the bat. What the heck is a fan coil?
A fan coil is basically a way of transferring either a cooling temperature or a heating temperature into a room by way of a fan and a coil section. So these are manufactured primarily to transfer that medium, whatever happens to be, if it's coming from a boiler, which produces the heat, or a chiller, which is producing the cold water, is pumped through a fan coil, and by way of a control or a thermostat, it's going to either throw cooling into the room or throw heating into the room.
So let me stop you there. We're just talking about what? It's a box with a coil and a fan.
That's pretty much the case, and there are different sizes based on different configurations, based on different amount of cubic feet per minute, or CFM, that you need for a particular room to meet the temperature requirements of that particular room.
Okay.
Ken, before we get too deep in, tell me a little bit about your history in the industry, how you even got into HVAC, when you got in, and what you've seen throughout the years and where we're at now.
How many hours do we have for this? Now, I began many years ago, well over 30 years ago, in what I refer to as the heat transfer industry. But heat transfer touches many different areas of the world, whether we're talking, well, it's basically a general category that I use. But anyway.
So are you an engineer by trade, or what's your kind of background before you got into the industry?
No, I was a philosophy major, actually.
Okay, so, and you had a incredible fascination with HVAC, and you jumped into the exciting world.
You could say that. Actually, I came back as a returned Peace Corps volunteer after working in Lesotho, South Africa for a couple of years.
Nice.
Looking for a job, and I started working at a company by the name of Russell Coil Company that was in Brea, California.
Okay.
Lesotho, huh?
What did you do? What did you do in the Peace Corps?
What I did is I trained teachers how to teach.
Oh, great. Nice.
So that was basically what I did. But one of the things that attracted me to this particular career, and one that I've stayed in for the last 30 years, is that it was beyond fascinating. So not having an engineering background was not a deficit in actuality. As a philosophy major, what I found it made me do was think more critically of things.
Okay.
So I was able to pick up a lot more technical information, whether I was talking direct expansion using refrigerant or water, or whether we're talking heat pumps or things like that. So,
okay. And was this technology around 30 years ago? Like at what point did fan coils become popular?
Envirotech has been around for at least 30 years, and it's been popular since, goodness, even before that. I'm not sure who the first fan coil manufacturer was. But, whether we started with rooftop units with centrifugal blowers and compressors in there and blowing cold air down a piece of ductwork, or whether it was done by chillers and boilers, I can't tell you when all of that started, but it's been a long, long time.
So the fan coil, we've got a box. It's got some coils in it, and the cooling and heating sources are what? Which is what's getting. We know the water's getting pumped in.
Correct.
And what's cooling and heating the water for those fan coils?
Well, you have a boiler that's actually boiling the water to a particular temperature, and then by way of a pump, it's pumping out to those particular rooms that are calling for it. And when I say calling for it, it's the thermostat that's actually sensing what the need is in a particular room, and then allowing that solenoid to open and the water flow into the coil and let it do its heating. Reciprocally, you would have the same scenario with a chiller, which provides chilled water to a fan coil, again, by way of demand and control of the thermostat normally.
Okay.
And then what? A fan just blows over that coil at the same speed?
It can vary. Normally what happens is it starts at a very high speed if a call is made, and then it will ramp down. You can basically these days have 3-speed motors. You can have variable speed motors, primarily on the electronically computated motors, the ECM motors. I shouldn't say ECM motors. M is motors, so that's being redundant. But with the calling of what is need for that EC device. So it basically will ramp up, but usually the T-stat will start in the high end and then start ramping down as you meet set point, and obviously there's a very variable in there.
So it's not just starting and stopping
no.
right when it meets
Nope.
set point? Okay.
Nope, not at all.
How involved is Envirotech in last week we had a water treater on. How important is the water quality to the efficiency of the fan coils? Sometimes, some scenarios it's more than others. How does that fall in here?
Yeah, that's a very good point, because depending on how the flow rate or the type of water that's in there could obviously cause major issues with deterioration, with calcium buildup, and thus people will put some type of treatment in there on in their systems to make sure that it flows very evenly or should I say consistently through your units. Now, not everybody uses a glycol, and glycol isn't meant for necessarily fouling of pipes, but that's more of a deterrent on low temperatures to make sure your water doesn't freeze in the pipes and then expand the pipes and then cause leakage. So you're talking basically about water treatment for outside fluid coolers, or not fluid coolers, but water-cooled condensers, evap condensers, etc., to make sure that water treatment stays in a manner that doesn't foul up your system. And that's on the heat rejection side.
Sure. What is the ideal building type and scenario for this technology?
Any high-rises that you have, that includes 5-star, 4-star, 2-star hotels. We did the Korean Air building, largest skyscraper west of the Mississippi. We just finished off last year using our low-profile type of unit, again, depending on how the design requirements are by the engineer, whether it's an above-ceiling unit or it's something that actually fits in the wall or a closet type of application.
Nice.
So you mentioned the largest high-rise west of the Mississippi. So when you're sizing a building like that, do you take into account like any redundancy? What if they're all the fan coil units are calling for maximum cooling at the exact same time?
That's an interesting question. Normally that would not happen because you've got the sun effect on a building. So, for example, first thing in the morning, the east side of the building is going to be heated a little bit more than the west side of the building, which probably is still going to be calling for heating. So when you design your building, you design it for the capability of those variables within the system and what you're going to need. It would not necessarily require you to have the whole building and cooling all at the same time unless you're having a major meltdown. What is interesting also is that if you design a building, sometimes people use an N+1 where they'll use 2 chillers as opposed to, say, 1. So if that one chiller needed to go offline to do cleaning or whatever happened to it, normal maintenance, your whole building wouldn't be down. You'd be able to go with the backup system, and the same with the boiler.
Right, but you don't have that, let's say, for your room, right, with the fan coil unit.
That's correct. And like I say, normally all the rooms would not be calling for cooling at the same time.
Right.
Yeah, that's it. It very rarely happens. Although, with for those of you that believe in global warming, and those of you that live in Southern California and going through all the heat that we had last year, that may come into play, where you have to design a system that has the capability of maybe 3/4 of the building requiring cooling, as opposed to maybe just half or 60%. I'm not sure what the actual number is that engineers design for, but you do have to make sure that you're covered. It's kind of like you're taking a shower in a hotel in the morning, and you want to make sure that all the rooms have hot water. So you're making sure that you have a boiler that's going to be able to contribute to everybody having hot water that's in that room. But again, even in a hotel, you don't have 100% occupancy. You have a certain amount that are there and certain that are not. So you don't want overkill, in other words.
Right.
So you mentioned a little bit about global warming. I'm not going to get into that, but I thought of efficiency. Why is this a better solution than just moving air around a building?
Well, part of what you're having to do is you've got to figure out how you're going to best control that water flow, whether it's hot water or chilled water. And the other thing you have to make sure that you do is you have a coil that optimizes the efficiencies. For example, when you use a different size, what are some of the variables? The variables would be how you circuit that coil. In other words, you may have a coil that has 2 circuits in it. You may have one that has 4 circuits in it, depending on what your pressure drop requirements are within that building and within your design requirements. So that's something that's, again, left up to the engineer. But what we try to do is offer the capacity in our selection program to accommodate for those choices by the engineer, whether it's an existing building and they're retrofitting, or whether it's a brand new building and they're starting from scratch.
Okay. Now, you guys make VAV products as well. And let's start very basic here. What is a VAV?
Variable air volume. It's basically a way of controlling air going down a piece of ductwork, and it's usually built in conjunction with a rooftop air handling type of unit, and it's basically a way of distributing the cool air or hot air to a particular location.
So here now we're talking about moving air, and typically you're not going to find fan coils and VAVs on the same job. That's
correct. Normally, VAV products are primarily for either non-heating or heating applications. They do not come with condensate drain pans in them, and that would be if you had cooling inside your room, and you'd have to have a very tight envelope, and by envelope meaning your building had to be extremely tight and not with a lot of air leakage going in the doors or through the windows or anything else, because that could cause issues. But from the heating side, that's not so much of a problem, but it would be on a cooling side. But yes, VAVs are all for heating and just air movement, air distribution.
Do companies similar to yours, are they doing fan coils and VAVs, or are you unique that you're doing both of these?
No, most of our competitors are doing both, I would say. Some are offering a wider range of product offerings when it goes into direct expansion. You know about the VRF systems that are out there, and Envirotech is not about that. Mm-hmm. Are the major players on our side of the fence are Williams and International Environmental, Train, Rittling.
So it makes sense that if you're going to manufacture a fan coil unit, you manufacture a VAV box as well. So what's the big difference there?
Good question. It depends on what the building design is calling for. But you're moving heat, or excuse me, you're moving air around a building. So how you move it and how building is designed is going to basically dictate whether you're using fan coils or whether you're using just VAV products, which again are more closely aligned with rooftop units, whereas fan coils are more aligned with boilers and chillers and having a machine room for those.
Right.
So
the big difference, a VAV box has a coil, but also what, can have electric heat?
it can have electric heat. Yes. It'd either be electric heat, it'd either be no heat, electric heat, or hot water.
Okay. And then it also has a fan.
VAV products do not normally have a fan. They're at least the standalone units are. We do offer series and parallel flow VAV products that are meant to work in conjunction with air handling units. And they do offer heating and cooling. I kind of refer to them as a poor man's fan coil, but it's a way of again moving fresh air in, but making sure that you pre-treat that air before you dump it into the comfort cool area. But yes, you do have parallel flow and series flow.
So if fan coils and VAV boxes, are they a potential source of sound? Are they a place where at that point we can deaden sound? Tell me a little bit about sound in these pieces.
Yeah, sound is created by, it could be any number of things. It could be discharge air sound. It could be air itself. It could be a rattling or discharge off the unit that would create a different type of sound. There are sound attenuators for VAV products that kind of deaden the sound if it's in places like hospitals that you don't need that, or libraries where you want to basically make it as close to white noise as you possibly can, so it's not a disturbing factor in your envelope.
But you still want the white noise, right? Is there such a thing as having it too quiet that, like in a library, you would hear the rustling of papers and it would just drive you crazy?
Yeah, I think it would depend on whether you want to take a nap that day or not. But no, noise can potentially be bothersome. The white noise is not so much. If you're sitting underneath a supply duct and you're hearing noise or it's constantly on, that could be annoying. But I guess it depends on how great that sound level would happen to be. Sound level in our industry, can be aligned with either decibels or NC levels. NC levels are normally equated to what a particular design in a room entails. For example, in a hotel room, you would ask about an NC level if the room or if the bed was positioned here, the sofa was positioned here, the armchair was positioned here. What is the NC level? The problem with that, obviously, is all rooms are very different. So we've tried to standardize that and make it more of a decibel reading type of scenario. Mm-hmm. And I'm not sure that's officially adopted yet by AHRI, but if it's not, it will soon be. So
what's new in the last few years, or even 5 to 10 years, with fan coils and VAV boxes, or has it stayed pretty flat?
It's as a sales manager, we like to get excited about this stuff, but
Sure.
As you well know, it's like maybe not the most exciting thing in the world. It's like telling dad jokes,
Which I love, by the way.
Okay, well, I won't throw any dad jokes in here. But anyway, I think some of the exciting things that have transpired are the significance as far as the quality of product that's being put out there. Make sure that if, from our perspective, it's something that deals with making sure that end users don't have an issue from the get-go. It's making sure there's higher quality in, as far as leaks on the coil, as far as sound attenuation, which we just discussed. Make sure that we offer, from our perspective, offer as many solutions as possible so people have choices. Some of the things that we see coming down the pike, though, are kind of a consolidation, for example, on the valving that is out there. The 6-way valve is raising a lot of interest by many people, or of many people, because of the fact that it takes away the complexity of adding a solenoid valve, a shutoff valve, a control valve, an autoflow valve, proportional valve potentially in a system, and have them be separate valving. All of this could potentially be one valve in particular.
So hold on. When you talk about these valves, where will you find these in your system?
They would be the feed valve that would be actually attached or very close to the fan coil itself.
Okay.
So, and they're primarily on fan coils. We probably eventually will get to the point of putting them on a blower coil, which is a little bit more of a challenge just from the standpoint that you've got a bigger unit, bigger CFM, higher the water flow, and we're not exactly sure that the orifice size that are in six-way valves in all applications are going to be workable. We're starting with the fan coils right now, and that's what we're staring at.
Let's back up, and you mentioned the six-way valve. A couple questions. When did this come out, and what problem was it solving that this was invented?
Well, when a project is put in and a fan coil is put in, there are several valves to control the heating and the cooling. Obviously on a fan coil you can have it in the heating mode, and that could be electrical, so you don't have to worry about that. But because of efficiencies these days, more people are going away from the use of electricity because they're terribly inefficient.
Okay.
So what they're offering is on a control valve, or on a fan coil, you have the opportunity to have a heating coil as well as a cooling coil inside the housing of a fan coil. Now, instead of having two separate coils in there, one doing one function and the other doing the other function, potentially you're doing away with at least one row, possibly even two rows of the heating side, because a six-way valve will actually allow you to put that fan coil into a mode where it's either in heating or it's in cooling, but you're using one coil, not at the same time. And like I say, it's either going to be in heating or cooling to do the function that it does. But as you are well aware, in a cooling scenario, you usually have 2, 3, 4 rows of cooling. On the heating side, you may have 1 or 2 rows of heating. Mm-hmm. So if you're basically taking out of the equation 2 rows, 1 or 2 rows of that heating side, that makes your unit a lot more cost-effective when you're selling the product to a customer. And considering that you're taking away maybe 3 or 4 valves and you're only using one valve to control both the heating and the cooling on that unit, that offers a savings as well. So it actually, just takes away all the complexity that's in there and offers some economic solutions.
Can you give me a ballpark on, I don't know, a Marriott hotel by using this solution, maybe percentage of savings?
Yeah, just upfront costs, you're probably looking anywhere from 5 to 7% on mechanical, and by mechanical I mean the valves and doing away with the extra heating coil that's in there. Mm-hmm. On efficiency side, something we didn't really talk about, and that is when you're using this valve, instead of having 1 or 2 rows that you're using for heating, you now have this coil using the chilled water side, which is either 3 or 4 rows. When you have 3 or 4 rows to dissipate what was previously used 2 rows, now what ends up happening, instead of temperature of your hot water going in at 180 degrees, it can now come in at 140 degrees or less, maybe 120 degrees, which then leaves open the opportunity of, instead of using copper, of using potentially PEX as a way of basically putting in your piping through your system.
And how long has this valve been around?
I would say maybe about the last year and a half or so, somewhere in there.
Are there several manufacturers of this?
To my knowledge, there are only 2 right now, and those are Belimo and Johnson Controls.
Okay.
So
is this has this been used in the field at this point?
Yes, it's in several jobs, of which I don't have the names for right now, but I know it's being used. I know when Belimo first brought it out, they had put in a lot of I shouldn't say a lot, but it solved a couple of issues when it came to the valving opportunities on some of the larger jobs. There were things you have to take into consideration. That is the flow rate of some of the valves. The C sub V that you offer in our competitor's valve is not as high. Potentially, if you have a liquid medium, your water that's in there is not particularly clean, or it's full of calcium, you could potentially, because of the smaller orifice size, have a fouling problem, which you want to stay away from. But you wouldn't necessarily have that if you kept your flow rates up and you treated the water in advance. So,
Okay.
You're listening to Engineering Tomorrow, always striving to bring you the best in commercial construction, design, and engineering.
So you guys, looks like you're also making blower coil units and air handling units. You want to tell me about that a little bit?
yeah, the blower coils we've had for several years. The industry as a whole is going away from a belt-driven blower coil. Belt-driven blower coils are obviously, as their name implies, using belts and shims and sheaves to adjust the actual CFM on units. They're good at overcoming static. But what has been happening recently is there's been a major push to bring in the electronically computated motors, which is not only offered an efficiency savings on the one side, but it also offers a savings on for the service side, because no longer are you dealing with the dust that's produced by the belts that have been used for years out there. So a lot of people are just going away from that, even just for that reason, just because of the mess that it produces. So,
could you go in a little more detail on what exactly an ECM motor is for those of us that don't know?
Electronic computated motor is basically taking an AC signal and dropping it down to a DC signal.
Okay.
It has a special controller in the end bell, or at least it's normally been in the end bell of the motor, that allows the efficiency of that motor to evolve. It basically is not using a brush type scenario like the old AC motors used to use. So there's a lot more to it than I'm describing here, but it's very efficient, and it's the most common thing that's happening as far as efficiency goes in our industry right now, even with compressors. So, yeah,
I'm starting to see a lot more. I mean, over the last 3 years or so, just with everything, it seems like that's the way everything's headed for sure.
No, it is. Even with the air handlers, blower coils, and as you can tell, we started with fan coils on EC motors. Blower coils now have them, which notoriously are for larger applications, larger CFM, higher static pressures within a system. And what this allows you to do, the motor from those transitions have been bigger and bigger and bigger. Now, air handlers, I think they're now producing air handlers in the 2, 3, 4 horsepower range that are EC motor designed, and they are available out there, I believe. The air handler that our company happens to have basically goes from I'm trying to think of what CFM I'm going to say, maybe about 500 CFM to about over 9,000 CFM. It's a small air handler that's particularly designed to go in facilities such as hospitals where they don't give you a lot of real estate to put equipment.
Okay.
So,
and how long have you guys had that product?
We've had it ever since I've been on board, so I'm going to say at least 15 years plus.
Okay. I want to give you a little bit of an opportunity to talk specifically about Envirotech. Tell me a little bit more about the history of Envirotech and where we are now, and then we'll dive into maybe some benefits of your solutions versus some others.
Okay. I'm trying to remember when we came into being. I think it was the early 80s.
Okay.
And Ken Rawson was the gentleman that owned the company, really good salesman. At the time, we were producing several products, several fan coils, the HPs and HL units that we currently offer, along with our VAV products. But part of that was brought out after a marriage with Metal Air at one particular point in time. But we've grown and developed our own standards, our own qualities that we put into our units. I believe, back in 1980, I can't remember whether now it was 80 or 90. I believe it was in the 90s. Envirotech was purchased by Johnson Controls, and we have been a working partner with them for quite some time. And JCI is a company that never stays very stagnant. They recently, I'm talking about the last 5 to 6 years, made an acquisition of the Air Distribution Technologies Group, which encompassed the Ruskin, the Titus, the Kruger, Lau, trying to think all the other companies that resided within that group, but they did purchase that group.
Okay. Where are you guys located, and where's your manufacturing facility?
Well, we're all based in Largo, Florida. All the manufacturing complexes there. We recently have moved into a new facility. We've got state-of-the-art sound room, so we're making sure that everything falls in accordance or below standards, so we can make sure that we have talking points with our representatives and with engineers out there, and obviously a big point in trying to beat our competition. So
sure. So let me touch more on that. We've got, obviously we've got a couple different competitors within the market. Tell me why Envirotech? Why would I want to go with Envirotech?
It's in a nutshell, it's a better designed and a better fabricated unit that's out there. It's been consistently built and consistently refined. Some of our competitors have gone through some different buyouts, different management people, which hasn't been. They've been a contributing factor to their. What do I want to say? The amount of non-innovation that's occurred out there. With us, we've been able to continue to do what we do and produce the quality products that we produce, not necessarily with the help of Johnson Controls, but they have obviously been a factor to help move us along, to encourage us and make the units the way they are right now. And right now we've got some cutting-edge designs in our products that would put most of the people to sleep that don't deal with heat transfer, but we find them exciting anyway. So
when you say, sorry, Brian,
go ahead.
You said, you manufacture and you design, you build all of these units. Are you actually physically doing that? Because time and time again, you see with some of these large manufacturers, they buy parts and pieces and assemble these products based off of their design. But you said you have a whole manufacturing facility. Do you know, if there's a small percentage of parts that you're getting?
No, all of our products are built in America. Okay, we do get some of our sheet metal from Canada, but I think the vast majority of them are through manufacturers here in the United States. Motors, for the most part, we've used some of the local suppliers, but we find most of the EC technology has been developed very astutely offshore, so we've been using those motors. But all of the products that we build are built down in Largo by our own people, which I might admit, and you kind of enjoy going down there and seeing all the flags of all the countries that are working there in the assembly plant. But we use a just-in-time manufacturing capability, so we don't have a lot of parts, pieces, and things laying around. We basically, once we get an order, have a supply chain set up and manufacturing process set up where we are able to assemble all the sub-assemblies, then bring them all together within the last day or two, put them together, and then ship them out.
What is your typical turnaround time when I place the order? How long typically are we seeing before it gets out the door?
We offer options of a 5-day, 10-day, 15-day quick ship, depending on the products. The 5, 10, and 15 are primarily for fan coils. For blower coils, it's more like 10, 15, and 20-day. If you if you ask for something that is not in our selection tool, that will have to be a special quote and a special designed item that has to go over to engineering, who produces the drawings, releases those the drawings to the factory to make sure that we build it correctly. So one of the things I might add here is at the beginning when we were building standard units, there were a lot of requests by reps, by engineers, that we build something special. You know, can we add a particular sheet metal piece here, or can we add a control piece or a sensor here? And I can say that one of the things we've done, and done very successfully, is to be able to produce and offer those to customers as they need them. So we call those SQs for special quotes, and we've got well over 6,000 of those sitting in our that we've done over the years that we still use to this day. So we like to feel that we have the flexibility to still do the special things that might be required by the field.
Kenton, what are some of the most common questions you get asked during presentations, specifically from engineers?
I'd like to say that I leave them totally baffled and they don't ask a lot of questions. I wouldn't say there's anything that's terribly typical. They're usually atypical about about a particular product line. For example, the six-way valve and its application. You know, is it going to be as efficient as we say it is, and how would you get down to that point? Is it going to cause issues on using heating, and how do you do bypass with valves like that, et cetera? So they're all good questions, but those are some of the ones at least related to the valve. But fan coils are not a real complex product as far as how they're fabricated, how they're made. But it's very important that customers get a feel for how they are made and the qualities that go into those, because we recognize that those engineers are also salespeople. So they have to be able to, when they choose our product, explain to the end user, we're using this because of efficiencies or serviceability or the ease of installation, any number of criteria. So,
are there any tips you can give engineers when they're laying this out?
You mean the valve or the fan coils?
Everything.
No, just contact your local representative and make sure that they're properly supported. And if the representative runs into issues, we work together to try to resolve those, whether it be spacing type of scenarios, whether it be quick turns, when it comes to air distribution. I'm just trying to think of things off the top of my head that might throw curveballs, but most of this is pretty straightforward stuff that is pretty easily handled. So,
how about at the contractor level? Any installation tips, things to look out for, things that you've seen that maybe do it this way, that way, anything like that?
Well, one of the reasons, funny you asked that question, that we brought out the six-way valve is there is some complexity as far as sizing of valves, making sure you have proper orifices in auto flow valves. And if you've got, let's just say, a job that has 200 units in there, and you've got hot water and chilled water, you've got shut-off valves, times 2 of each of those, times 2 for the auto flow, times 2 for everything, and making sure you have the correct sizes assigned to the correct blower coil or fan coil, I should say, is sometimes a little bit of a struggle. Most of the contractors know how to deal with it, but there are some others out there. We found some installations where it's like, who in the heck put this in?
Yeah.
So
I think that kind of goes towards, the rep in the area, making sure that they're planning with the contractor and engineer, and everyone's on the same page before everything gets installed, and that all those questions are answered. I think that can also help a lot. No,
very much so. I always recommend, even on small projects, or if a customer is not familiar with the product, if they have the capability or the time to try to make a trip down to our Largo facility that it shows very well, has a good showroom, and manufacturing complex is very well laid out, and people are pretty much impressed. But I also recommend sometimes purchasing a mock-up unit, because that kind of takes the worry and question out of the people's minds as to the quality of product that they're potentially putting into their building. And when they see that I can honestly say with an extremely high degree of consistency that once they see the product, they're sold.
Nice.
We've had occasions where we've laid out our unit against our competitions, and we've walked out of the room and just say, you guys look at it, you evaluate it, you take the time and kick the tires. And invariably, the guys walk away and say, I want the Envirotech product.
Great.
So
I think I'd probably be able to tell a little bit better if I was down in Florida myself. But yeah, a mock-up unit.
Knowing that the fishing and the golfing is better down there, not to mention Disney World and Universal, and those are attractions too.
It's not a bad trip.
It doesn't sound too bad.
No.
Kenton, Steven, do you have any other dying questions or things you'd like to know?
Oh, not today. I think we've pretty much covered everything that I had questions about. I appreciate you taking the time today.
No, I appreciate having the opportunity to talk about it. I feel after today I'm a little bit talked out, but other than that, it's the end of the day. But I appreciate having the opportunity to kind of express this, and I hope it's been worthwhile for the audience that's going to be reviewing this. So.
Yep. And to get in touch with Envirotech, obviously they have their local reps throughout the United States, as well as their website, enviro-tec.com. So it's enviro-tec.com. Again, thank you guys for tuning in, and looking forward to seeing you on another episode of Engineering Tomorrow.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.